right, so as I said, it's time to start filling out the initial functionality of handling adding items here in the inventory component. You might notice my writer's looking a little different. It's actually been several months since the last video. A lot of stuff happened. I had COVID, and then other stuff got in the way, and so I had to put my tutorial series down for a while, but I'm excited to be getting back to it. So let's get right to it with the handle add item. That's where we're going to start, because that is the entry point for any time a new item comes into the inventory. The class responsible for adding that item will be calling this function. So right when we start, one of the things that we want to check is we want to make sure that the inventory component we're trying to add something to is a valid owner. And again, like with many of the other functions we've written, this is just a safety check. And then what we're going to do is we're going to create a variable. I'm calling it initial requested add amount. And this is equal to the input item quantity. The reason for this is just because it's easier to have this in one place. As this function grows, you will be, doing some other logical checks on things, especially when it comes to the handling of the stackable items. So it's just a little bit nicer and a little bit more understandable if you are looking at, oh, okay, this is how much I initially tried to add versus this everywhere, which is a little more vague for the purpose of the function. So since we're only going to handle stackable items right now, we'll start with that. But I'm going to put a little bit of placeholder code in for I meant to say non-stackable, I think. We're going to put in a little bit of placeholder code for the stackable stuff as well, though. So for non-stackable, all we have to check is our input item in the numeric data, that's where the Boolean is stackable. But we want to invert that because we want to handle it if it's not. If it is not stackable, then we will call return handle non-stackable items, passing in the input item and the initial requested add amount. One thing that I realize as I write this that might be worth revisiting is that, if you have a non-stackable item, you should only ever have one. So it's a little goofy to me now looking at this to have an add amount that you pass in. That could be an easy tweak to the functionality. But, as I go through this, I'm looking at some old code and stuff, and sometimes you just realize those things as you go and kind of optimize on the fly and stuff like that. All right, so this would be the only thing we need for the non-stackable. So now down here, we're going to put in a couple placeholder things for the stackable code. So again, we're creating another variable. This time, I'm calling it stackable amount added. And this one is calling handle stackable items and passing in the same stuff, the input item and the initial requested add amount. But the reason why we're having this variable here is because stackable can have multiple different states when it returns. You can have added none, you could have added some of it, or you could have added all of it. So we're going to do some checks based on how much was added and then return an item add result matching the state. So first you would say, okay, well, if the amount I added is equal to my initial requested add amount, you would return added all result. Otherwise, if the amount I added was less than the initial requested add amount, but also greater than 0, then you know you must have added a partial stack. So we would return added partial result. And then lastly, if the amount added is less than or equal to 0, which should never be less than, but just to catch all there, then you would return added none result. So that's pretty straightforward. I'm gonna hold off on creating the add results since, you know, handle stackable items is not gonna have any code for a good while. We need to make sure that we've got the initial chain of logic for non-stackable working, and then go build the actual inventory screen that'll show items before we worry about stacking, you know, stackable items. Okay, so that is handle add item. So now let's go ahead up to handle non-stackable items and start filling it out. So non-stackable items are pretty easy. We just have to do a couple of checks, and then we call add new item, which is the entry point for the actual modification to the array. This is where something gets you know, added to our inventory contents array. So the first check we want to do, we're going to use if math is nearly zero, and we're going to item in it's called input item get stack weight, get item stack weight. If that is nearly 0, or input item get item stack weight is less than 0, we want to return added none. This time we're gonna fill these out for each one. I'm just gonna write the core logical checks first. Okay, so now this is a check to say, you know, check if in the input item has valid weight. This should never be true, but it's a check so that, you know, maybe you accidentally put down a new item in your world and forgot to fill out some of the fields, then, you know, it'll catch right here. The next thing is we want to look at our inventory total weight and say if now inventory total weight plus our input item get stack weight is greater than our get weight capacity result, again we would return added none. So you might be wondering, you know, why are we using a stack weight in the non-stackable? And the reason being is just that it's just it's really a generic check, right? Because as you can see, it just multiplies the weight by the quantity. In this case, we know the quantity is 1 for a non-stackable. So you could just do input item get item single weight. It should be, you know, totally fine. I had just defaulted to using stack weight in mine. But yeah, it doesn't matter either way. I think I'll go ahead and change it to get item single weight, because if we look, see, it just returns that versus this one multiplies it. So sure, we'll save ourselves a little multiplication there. Okay, so now this is now saying, okay, we've checked that the input item has valid weight, but now we need to say, will the item weight overflow weight capacity? Okay, and so then we then have to do the one final check. Now, if our inventory contents dot num, which is just going to give us the number of things in the array, plus 1 is greater than our inventory slots capacity, again, we add none, because in this case it's saying, you know, adding one more item would overflow slot capacity. Now, if all of this passes, if none of these, return statements are executed, then you will fall down here to the bottom of the function, and now we assume it's safe to add the new item. So we're going to add input item, and we're going to add the requested add amount, and then we will return added all result. All right. So as you can see, the logic is pretty simple and pretty straightforward. The thing that's going to make this function feel a little bloated is that these results here, they get a little bit, I don't know, the formatting of it is a little bit hectic to me, and so it makes the function feel a little disorganized. You'll see what I mean. So we're going to return an f item add result, added none. And if you remember back from when we made these helper functions, added none only takes in an error because there's no math that needs to happen, right? It's just information to you. Say, hey, this failed. So, and also, if you remember when we made these, we made static functions, and this is exactly why we did that. Is so we don't have to create a new item add result and configure it first. We can call this function directly, and added none creates an item add result inside of itself and then returns that to us. So for our error message, what we're going to do is we're going to pass in an ftext format as the first, as the input there. And the reason we're using format is because we want to be able to put variables into this text string. And so the next thing you need is you need an ftext from string. And our error message is going to be could not add to the inventory. Item has invalid weight value. Let me go ahead and indent because this is ugly. All right, so now you may be wondering what's going on with this right here. So using ftext format, there's a kind of shorthand convention to where you can reference, essentially view this as arguments, right? So here on the non-stackable item function, we have argument 0, argument 1. It's just like that. Argument 0 to the format will then be, whatever you pass in, this 0 in brackets will be replaced with that. And so what we're going to do is right after the parentheses for the string, we're going to give it the variable we want to replace that 0 with. So in this case, we're using input item, text data, name. Okay? So pretty straightforward there. And this way, when whatever you're trying to pick up, this will print out in the log and it'll give you the actual name there and make it pretty easy to understand what happened. So let's copy paste this to all 3 of these added nones, because all we're going to do is change the error message a little bit. So now for this one, item weight would overflow capacity. So you can just say, item would overflow weight limit. And then this one, all inventory slots are full, something like that. Obviously feel free as always to change these messages, these messages to whatever you feel is best for you. Okay, so pretty simple there. Now let's do the added all result. So added all. Now remember, added all is a little different because it takes in a message, not an error, but also takes in the actual amount that was added. So in this case, since we assume we won't get here unless we're adding everything, just go ahead and put requested add amount as your first argument there, and then you're good to go. And then we can change this and say, successfully added item name to the inventory. Oh, and you know what? To demonstrate how the formatter works a little bit more, go ahead and actually give yourself a second text there, and you can actually put your requested add amount here as another argument to the formatter. So now you'll actually see, you know, added one blank to the inventory is what you should get out of that. So there you go. The, you know, it's I guess it's not nearly as messy as I kind of said I thought it might be, but pretty straightforward. And the good thing is that now, you know, we're getting a lot closer to being able to test this and actually pick up some items. So now we're handling the add item, which right now, since we're only going to put a non-stackable thing in the world, the execution should only go here. We then go through handle non-stackable, and we will get down here to add new item. Okay. So let's take a look at this. When we're adding a new item, through my experimentation and debugging, creating all of this, I realized that because everything is a pointer, all the items are pointers, you can run into some strange situations. And so I added some logic to compensate for that, and I'll explain that here in a second. So the first thing we want to do in our add new item is create a new item base. Then what we're going to do is do some checks here. And these flags don't exist yet, but they will. And we're going to add them here in just a minute. We want to check, is the item a copy or is the item a pickup? If it is, new item is equal to the item coming in. And then we would call a function that we're going to add that's reset item flags. Otherwise, if none of this is true, then we say create item copy. You may remember we added this function in the item base class. Once this block executes, we now have our new item. So we say new item owning inventory is equal to this. We then set the quantity to amount to add. For the inventory contents, we just call add and we add new item. So there's where it actually now becomes part of the inventory. We have to adjust our weight. And this time you do want to call get stack weight because you could be adding a stack. And then the last thing we need to do is we need to broadcast on our inventory update delegate. So that way all UI elements can reflect this change, you know, to the inventory, the weight and the item itself and everything like that. So let's go over to the item base class and add in these missing pieces here, and then I will give you more information on why this is necessary. So first thing we want to do in item base is just here at the bottom, we want to add a couple booleans, is copy and is pickup. And we want to add the function void reset item flags. Doesn't need to return anything. I'm going to go ahead and make a definition of that. So now we've got all three of these things filled out, so we're good to go. But we need to do a little bit of initialization here. So maybe, I don't know if I covered this in a previous video, but this is on a constructor. You can do what's called a member initializer list in C++, and that will let you initialize some variables at the time of construction. So it actually, when it goes to call the constructor, it will run this initializer, and then it will run what's in the body of the constructor. So we're just going to initialize B is copy and B is pickup, both to false, right when the class is constructed. And then with our reset item flags, that's just a way for us to manually call that, after construction, in case those things are modified. But when we put it into the inventory, we clear those out. Also, here in create item copy, we want to say, item copy B is copy is true, since we're making a copy. And I think that is all we need to worry about. Yeah. Okay. So now, why is this even necessary? And it all comes back to the pointers, like I was talking about. So here, let's have some diagrams. All right, so this is you as the player, and here's your inventory. Okay, and so now let's say, so then we have the level, and this is the memory space. Pretend this is the memory for the level. So any items in the world are in this memory space, okay? Now our items are pointers. So let's say you have a, let me think of a good example here. So let's say you have a chest, okay? There's a chest here, and there's an item inside, and you want to put that into your inventory, okay? So just this little circle is going to represent the item. So you come over to the chest, you open it, you then add the item to your inventory. Now remember, this item, it's in the chests array, but it's somewhere in the level as well in memory, okay? So let's say it's here. Oh, can I get a different color? Where's my colors? Oh, here we go. Okay. So this is here in memory. You call add new item, okay, with this memory reference that's here, and it gets put into your inventory array, okay? But now notice it's a memory reference, right? It's a pointer. So now this pointer that's in this inventory is also in this inventory. And what's going to happen then? Well, now, if we try to do something to one of them, then the other one gets affected, and everything is just all mixed up because it's pointing to the same exact memory location. Same thing as if it was a pickup in the world. Say we got our little potion bottle here. If we go and we pick up this potion bottle and it gets put here into inventory, again, they're both pointing to the same memory location, unless we do something about that and we make sure that it is now a new piece of data. Now the pickup, for a pickup, so the reason why, okay, that was a little bit, that gives the basic concept, but to further clarify, so the reason why, we don't create a copy if it's a pickup, because this assumes it's on the ground. This assumes it's something that was put into the world and initialized independently, and it's going to get destroyed once we pick it up, okay? So in that case, we don't need to create a brand new one. We just say, okay, the incoming item is now the new item, reset the flags, and then you can continue adding it. Because at this point, we would assume that the one in the world is going to get destroyed. But if it's, and also this, if it's already a copy of another item, that means we've already called create item copy somewhere else. So we don't need to copy it again. So again, incoming item is now the new item. Reset your flags, add it to the inventory. But now if it's not already a copy and it's not coming from the world, that means it's coming from somewhere else, and it needs to be a separate memory reference. Now, a perfect example of this would be our split. So we don't have the class that's going to actually govern the start of the split. But if you look, it's like, okay, I'm splitting it with the same memory reference, item in, and then I'm adding a new one of the same thing. And at first, this seems dangerous. Like, okay, that's going to do exactly what you just said is bad. But this would assume it's already in your inventory, right? You're not going to call split on something that's on the ground. This would assume it's already in your inventory and it's already had its flags handled and such. So when you call add new item here, it's going to look and say, okay, we're not a copy, a copy that's already been made, and we're not a pickup, so we must be a split or whatever else kind of scenario would lead here. So now you create a copy and then move down through the rest of it, add it to the inventory, and now you're safe. Your split has added a new stack, but that new stack is treated as a new item, which is exactly what you want. So that's that's why this logic is all here. It's a little bit weird, but it will make a lot more sense once we get further along into where we have stackable items and the inventory elements to let us, right click on it and say split stack. So put some comments here. If the item is already a copy or is a world pickup, otherwise this one is used when splitting, and in my reference I have dragging to or from another inventory. Because one of the things I built is containers where you can open it up and drag items back and forth between them. And so that comes back, I already closed it, but that's what my little diagram really was applicable to, is that, you don't want to have your memory reference pointing to the same thing in two different places. It just causes all kinds of bugs. All right, so now we've got everything kind of in place except for our stackable stuff. So now we need to go back over to, let's see, we got the flags in the item. We got all of that being taken care of. Add new item is good. We need to fill out the code we left, the placeholder code we left here in pickup. So pickup is, like I wrote here in these little comments, we're going to try to add the item. And then based on the result of that, which now you've seen, comes from your added none, added all, etc. We will then take action and adjust or destroy the pickup, or, do nothing if we picked up none. Okay. So let's go ahead and delete this. And right off the bat, I know we're going to have to make a few tweaks to the character class, because notice this function is not found. So let's go over here to the character. Okay. I tried to click like a go to and it didn't work. All right, so in the character, we need a way to get an inventory reference, because sometimes you need to be, for multiple things that we're going to do with this inventory and the UI especially, you need to be able to get the actual array. So first, let's actually add an inventory component to our character, because we haven't done that yet since it didn't exist, up until this point. So I will just come down here and say InventoryComponent, and writer's helping me out. What do you want to do? I want to add just a for declaration, and I'll call this player inventory. It wants it to be a U property. So for U property, I'm going to make it a visible anywhere, since you will never need to modify the actual inventory through the player like this, not directly. So this can be a visible anywhere, just it can be visible, but we're not going to change anything. And then category is character inventory. All right, pretty straightforward. So then let's add our force inline function here. Force inline, it returns an inventory component, a reference to it, and it's called get inventory. It's a const because it does not change anything, and all we're going to do is return player inventory that we just added. Pretty basic. And if we go back now and look at pickup, this fills out. Everything looks good. This is an if statement, so I don't need a semicolon at the end there. Now, one thing that before I forget, one thing we definitely want to do. So we added the inventory component just in the header. We need to make sure that we instantiate it on the character. So for that, we're going to come back over here to the constructor, and we're going to add the component or create the component. So create default subobject, and the template we're using is obviously inventory component, and we will call it player inventory. We then want to set our slots capacity to something like 20 and set our weight capacity something like 50. Okay. And it looks like it automatically added an include for me. Let me just kind of put this up here, reorganize a little bit. I try to keep mine, I don't know if I mentioned this before, but I try to keep my includes separate for ease of sorting, you know, rather than having one giant list and mixing in our engine stuff. So you might like that, might like to do that too. Okay, back in the pickup. So now we've got our inventory reference, and we're checking, you know, is it valid? We don't want this to be null. And we then need to take a look at our add result. So we don't have any add result yet because we haven't actually called handle add item. So create one here, f item add result. I'm going to add an actual include in this case because I'm in the CPP file, and I need the include for the inventory component. So we're creating a new item add result, and just call it add result equal to our player inventory handle add item. And what item are we using? Well, the pickup stores an item reference, and that's what we're going to pass in. Since now handle add all execution paths in handle add item lead to a return of an if item add result, we then have our result here that we can take action on. And we're going to use a switch statement, and what we're switching on is add result dot operation result. Because if you remember, the operation result is an enum that we created that comes back and says, oh, I thought it would let me jump straight to it. For some reason, my go-to isn't working here. So item add result tells us, you know, based on an enum, none, partial, or all. So those are the three cases that we have to handle here. So case add result none, partial, and then all. For none, you do nothing, right? You don't want to, there's no need to. We will already have printed out a message from the inventory if this happens for all cases. So the pickup itself is unaffected. For this one, we would call update interactable data, because what we're assuming, if you remember, update interactable data will now take whatever changed on the item and make it to where the interactable widget you're looking at is updated. And so in this case, you know, there's 5 in a stack, you pick up 2, you're aiming at it, you want to see that reflected in the UI immediately. So we call update interactable data here. And we also are going to call update interaction widget on the player. And so this is something we're about to add. It doesn't exist right this minute, but this is the one. So this updates the pickup quantities updated. This updates the interactable data of the pickup. This one actually updates it on the UI that the player sees. That's how it's going to go. And then for all, what we would do is we would assume in this case, then now the pickup has been fully added to the inventory. So you just call destroy. That will remove the actor from the world and send it to garbage collection and everything like that. So the only other thing before I go and update, fix this, I added a couple of little log printouts here. The first one being just a friendly information one here. So log temp, warning, text, and I'm just nothing but a single string. And what I'm printing is add result dot result message, and then you have to send it, call toString. And it's going to complain here and say like, hey, something's off. Right. Cannot print value type. We need to, any string we try to print like this needs to be dereferenced. And so there you go. So now, no matter what result we get, we're going to print out the message from the add result. I also wanted to do so. Okay, so we're doing a check here to make sure the inventory is not null. That is definitely something that you want to know. That would signify there's something pretty bad going on. So we're going to call our log here and just say, player inventory component is null. Oh yeah, I need another parentheses. There we go. And same with that, the item reference. This one we should not really be at this point with this being null, but it's always fine to do, just back yourself up with informational logs and stuff and safety checks. And for this one, I'll write something like pickup internal item reference was somehow null. Should definitely not happen, but just in case it does somehow, you want to get, some indication of that. Okay, so that is our core logic on the pickup, what happens when we go to interact with it. And I think that is good to go. Let's go over back to the character again and add in update interaction widget. And now with update interaction widget, we want external classes to be able to call that. So it's just going to be a public function, and update interaction widget, it's void, it's const. Go ahead and make a definition for that and put it in a way up at the top. I'm going to move this way down. I'll put this right under my other interaction stuff. So for update interaction widget, all it does is it will just do a check. So from the interaction segment, when we used target interactable, all we're going to do is again check if it's valid. And if it is, then we simply need to update the information on our interaction widget. So in our HUD class, we created update interaction widget, and we're going to be updating it with our target interactable data. So pretty straightforward. This way, immediately whenever this is called, whatever you're currently looking at, whatever interactable you're currently looking at, if its data changed, you now update your HUD being the interaction widget, and see the updates reflected right away. Okay, that is pretty much it for this initial pass through the inventory component. Just to recap, we started with handle add item because that is the public facing function that anything is going to call when it tries to add something to the inventory referenced by this inventory component. We're not dealing with stackable items just yet because we need to get the base logic working. So stackable, this is just placeholders for now. But we're going to call, we're going to add some non-stackable stuff first. We call handle non-stackable. Handle non-stackable obviously then does its logical checks and calls add new item. And I went through all the different, logic and reasoning as to why we need to be careful with that, with the memory references. And we have the core, the core important logical chain in place for picking up something and adding it to the inventory. So the next video, we're going to go over back to some UI work and start building up the inventory panel, add in controls for bringing it up, and make it to where we can see our items that we pick up. So yeah, let's get to it.